Hello, welcome back to CS 112 Computational Thinking. This is lesson 12.2, Random Lines. On the screen right now, you'll see a warm-up if you or your teacher is following the CS 112 program developed for the dual credit program. You may have this as a warm-up. Go ahead and take a moment and try and figure these out. Feel free to pause it. Um, what you're trying to do is write a little bit of original code, or give at least a code on determining when RGB or HSB, remember RGB, red, green, blue, HSB, hue, saturation, brightness, wouldn't be a better model to choose from. There are times when RGB is better to use than HSB, and there's also times when HSB might be better than RGB. In your posting, provide a code to fill a shape with different colors based on your selection. So whichever one you kind of feel towards. Historically, for me, whenever I've kind of put this to students, I find that kind of my more gamery, computer-esque type person, they like to choose the RGB option, where a lot of times my artist type students prefer the HSB idea. They kind of like the idea of a color wheel a little bit more. Um, like I said, there's benefits and kind of drawbacks to both of these. Include a short description of what happens in your code in the location that your teacher or instructor has kind of set that up for you at this time. Because this is recording, you can always pause it, and so I'm going to assume that if you need more time to work on this, you are going to pause it, just to kind of keep it moving for everybody involved. So today, like I said, we're going to be talking about random lines and kind of how to make these random lines. And this is where a lot of kids like to start having a lot of fun, just because the term random for them means a lot. A lot of times, random means a little more fun, a little more chaos, which we all kind of like to see every once in a while. So, moving on, from last time, we did talk about some processing statements, specifically that void setup in the void draw. We're going to be drawing some more shapes. We're going to use some variables. We're going to talk about order of operations, how to do random numbers, and what the print statement is. You'll also notice, if you look back at the warm-up, I was able to figure out how to make my processing a little bigger, so it's going to be easier for you to see on your screen. However, you probably won't be able to follow along with everything if you just try and jump around. You're probably going to be missing a bunch of stuff, so make sure you're following around so you don't miss, some void setup, something or other that suddenly doesn't make your program work. So we started about this last time, color mode. And there's another type, and it's called shape mode. And there's kind of specific ones. The ones that we're going to be using today are going to be the ellipse mode and rect mode. You can hopefully kind of look at that and say, interesting, that has the word ellipse in it. It probably has something to do with ellipses. Rect has the word rect in it, so that probably says, hey, that probably has something to do with rectangle. Um, they don't try and reinvent the wheel each time they name something. And so what we can do is these different shape modes can kind of change how we want it to work. And it might seem weird that we're trying to change how they work and like kind of what stuff we give them, but a lot of times it makes it so that you can be more accurate and you don't have to do a bunch of guessing. And it's able to kind of scale with your user's window. So there are four types of ellipse modes. There's center, which a lot of these kind of make sense. You go, okay, this makes sense. So there's center. Um, so again, we're talking ellipses, so these are the circle. Center is the default. It's already programmed there. You don't have to declare it whenever you first start off. However, this is how you get back into it should you decide to go with one of these other ones. So center, we give the center of the location in an X and Y scale. Remember, our Y goes down. It does not go up like it does on your standard Cartesian. Ellipse mode corner, it's kind of similar to one of those rect modes where you give it the upper left-hand corner location. Again, we're telling it it's the X size and the Y size. Ellipse mode radius sometimes is one of the kind of more commonly used ones if we're talking about something different than center. Um, Radius gives us, you can kind of imagine more of like that string that we go from the middle of our circle to the outside. Um, so it uses this idea of the we give it the center location, but we give it the radius for when we're talking the x and the y direction. Corners is a little more different. Um, it aligns with the upper left and lower right corners. You can kind of imagine those being two different locations. Um, the corner options are not as widely used whenever we're talking about ellipses. However, they are, and kind of to each their own in this. Feel free whenever we're kind of working about this. Um, Take a pause, go ahead and try playing around with those, see what the ones you like. Um, One thing that I will say is whenever you finish, whenever you're done, before you kind of like delete everything, go ahead and make sure that you put it back in this ellipse mode center. Sometimes, not always, the program will keep the last known mode and it won't change back even though you deleted all that code. Um, so go in, make sure you put that ellipse mode center. Again, if I am changing, and I kind of mentioned this last time, if I am changing these, regardless, I'm going to, at the beginning of my program, say ellipse mode center. The reason for that is if a user suddenly stops a program whenever it's in the middle of an ellipse mode corner, and then I start using center stuff, everything's going to be thrown off, and it's going to be hard to get it back. And so this is the idea of initialization. We've talked about it before, of initializing everything. Set everything up so that you're able to succeed. Rect mode, similar to that of the ellipse mode, we have rect mode corner. This is the default that we see. We have the X and the Y size. We're put it in the X and the Y location. Center is very similar to like kind of the typical center. You give it the X and the Y size and you say how big it's going to be altogether. So this is your diameter, if you will. Again, this makes a rectangle, so it's some people kind of struggle with this idea of like, wait, it's a rectangle, but we're giving it the diameter and stuff like that. You're really just kind of using the center point and you're drawing the square around it. Rect mode corners. This is a little more commonly used for whenever we're talking about rectangle, is we tell it the upper left and the lower right corners. Rect mode radius, again, kind of odd for some people whenever they're talking about a rectangle. This idea of like, okay, here's half the X and here's half the Y, and it's not that we're drawing it with like a string, um, but we are kind of using that idea of like, okay, this is how far it is from the middle to the edge. And sometimes, it's used fairly often. When it's used often, um, but it's not overly used from what my experience. Variables, we've talked about variables before. This is how we initialize or start variables whenever we're talking about variables in processing. There's three types that you should know of. Um, there's int, and that creates an integer. An integer is a whole number. If it gets a decimal, it kind of freaks out. There is a way of making it so that it can switch between whole numbers and float numbers, which we're about to talk about. Um, and so there's a way of doing it. It's a little tough at times. Float has a float is it has a decimal in it, which seems weird that, well, why isn't an int just have, the ability to do a decimal? And a lot of times ints can be used for counting the number of times that we've run through something. It can be used for things that we can't have half of or 0.4 of. And ints kind of help keep that a little more pure, and we don't have to take as much space with these random zeros at the end. Floats, especially important whenever we're talking about something like money or fractions or anything like that. It's a floating decimal, so it can have a large number of numbers behind that decimal number. The next thing is a Boolean. Um, a Boolean is, you'll remember, a yes/no statement. It's true or false, and it tells everybody that all we're looking for in this is a yes or a no. We can kind of turn it on and we can turn it off. true or false. So here's some examples. So we have int cats, so it declares a variable called cats, and we give cats the value of 5. Maybe we have 5 cats, or it has something to do with that. Float d equals 5.23223, and it gives it, we know, hey, this is going to have a decimal with some numbers after it, and the program knows to expect that. The next thing that we have is the Boolean red light. Now, kind of something, and we might have talked about it before. In variables, this is called camel case, and camel case is extremely helpful whenever we're talking about programming. The reason why is we're able to help denote different things. Instead of just saying red light all one thing, we're able to say this is a red light instead of kind of something like that. It also is pretty typical in programming language to have this camel case being that we kind of have some random capital letters in there. So in this case, we assign it the value of true. It's on, if you will. So if we checked, is it a red light? Yes, it is. Order of operations. In processing, the order of operations is similar to that of math. So PEMDAS. Hopefully you've heard that before. Please excuse my dear Aunt Sally. I think some people have different ones. I don't know those ones off the top of my head. Um, so a lot of times it's good to kind of get in here and just give, all right, this is what's going to actually happen. So you'll notice both of these are the same numbers. The only difference is how we have everything set up. The order of operations here gives two different results. If we were to do this example one, what would happen is it'd say, okay, there's no parentheses, there's no exponents. We're going to move on to multiplication. All right, we have multiplication right here, 4 times 5. There's no division. Again, and I didn't mention this, we go from left to right. And so it's going to do the first set of multiplication, and then it's going to do the first set of division, and it's going to do the first set. It's going to do it's going to be the first thing it comes across. It says, oh, there's times. I'm going to take the number to the left, the number to the right. Now, if there's something going on over here, it's going to kind of deal with that as it will. So in this case, we have 4 times 5. That's 20. All right, there's no more multiplication, there's no more division, there's no more parentheses, exponents. Now I'm going to go into my addition and subtraction. I go, okay, 3 plus this number is now 20. I got 23. Add on another 6, I'm at 29. Now, slightly different, I start with, on example 2, I start with, okay, I have 5 plus 6 inside my parentheses. There's my p. So I do my parentheses first. Exponents, no exponents. Multiplication, 4 times 5 times 11, which is this was 11. 4 times that is 44. All right, now I've taken care of my multiplication. I go to my addition. I got 3. My final result is 47. It is important to kind of know that. Another thing that is important to note is because you do something here and then you have something different on the next line, this first line is going to get accomplished completely and then it's going to move on to the next line. So don't expect it to kind of go between lines of checking your order of operations. It's going to do this line and then it's going to do this line. Random. Random is kind of a lot of, especially like what I've found kind of like the students' favorite thing is like, man, I just love to do random stuff. Um, so random numbers are going to be a float. Um, it's just kind of the nature of how they work. Um, so what we're going to do is we're going to actually start setting things so that they're random. If we give it one thing, it's going to pull a number that's greater than or equal to 0 but less than the number that we give it. And in NetLogo, we've talked about this, of where you have 0, you have 1, 2, 3, all the way up to the number, but it doesn't include that actual number. So in this case, we do have 30 numbers. The difference, though, is that we have 0 to 29. We don't have 0 to 30. We have 0 to 29. We still have 30 numbers, but it's 0 to 29. We can also tell it two specific things. We can say, in this case, we have 5 and 17. So it chooses 5 as a possible answer, and every number from 5 to 17 is valid, but 17 is not. It's going to be less than 17. This would result in 16 being the highest number that we'd get. So Right here we have a number, and this is kind of the thing I was telling you about before, of that we do have a way of changing a number from being a float to an int. Uh, we can actually say in here, and this actually converts it, and we can give this random actually a decimal value. And so what this does is we generate a random number that's greater than or equal to a 0, but less than 11.3. We change that into an integer by using this little set of code right here, and we'll kind of do more of those later. Uh, and then it stores it as I. And the reason that we have this int high here is we don't have to do that every time. We're first kind of starting it. I like to use the word initialization, or initialize, but it's confusing in that this is an integer, it's not initialized I. So let's have some fun with this. All right. So when we do this program, 1 second, I need to pull something up. Here we go. Oop, no. There we go. All right. So int I. So what this tells the program, and you can kind of maybe you can see it down here. It says, "Hey, I is not being used anywhere. Are you sure do you want to use this for something?" So what this does is it tells the program we have a variable called I. Just so you know, we don't have to set it equal to anything. We can do that later. But it says, "Hey, just so you know, we're gonna have this thing called I." Just so you know. Another thing, let's make a float j. Again, we haven't told anything, but we tell the program we have a variable called j that has decimals. Okay. Now j, we can set equal to, let's do that random that we just saw again, random 11.3. So what this does is it's a number greater than or equal to 0, but less than 11.3. I is going to equal, and what we're going to do here is we're going to actually change this j value, this value that we got for j, and we're going to set it to be a whole number, so an integer. We're going to change j into an integer. And what this does is it sets I to be the integer of j. Now, we haven't talked about this specific program, or this specific code right here that we're about to do. So what we're going to do is go println. Now, print ln. All right, you're like, okay, I got print, but what's ln? Print ln, print line. So it's going to print what we tell it, and where it's going to print it actually is down here. It's going to print it in what we call the console. This is called the console down here. You can actually see that it says console. You can click on errors and it's going to jump back and forth. Errors is kind of nice, and it tells you, hey, you're missing something, take care of that. And it also tells you where it's missing something. It's not always 100% accurate because you forget something and so it thinks it's in the wrong spot. Check the general area of where it tells you. Over here it says 9, so it says, hey, print like line 9, and the issue might not be on line. It might be actually on line 7. It's just line 9 is where it picked it up. So check the general area, see if you can find it. All right, going back to the console. You can't type in the console, by the way. I'm trying to type right now. I don't know if you can hear that, but nothing's happening. So print ln. So what we're going to do is the quotations tell it, this is what I want you to actually write. I want you to actually write this. And we've done this before of where we need to have this space afterwards, otherwise it kind of meshes all together. I put a comma, and we'll talk a little bit more about how the different things you can do with this. But we're going to say comma I, and I is just the variable. Then we're going to go, and I'm going to put a space here, so then that's not running into each other. J equals, I'm going to do another space, a quotation, a comma. one final thing. Let's put the j so that then we get that value for j. So what this should do is this should tell us what our I is, and I in this case is going to be it's going to be the integer of j. We're going to see what j is as well. And it's going to print it down here so that we can see, okay, how is this actually working? So I click the run button, and it's going to run it one time. And so it came up down here. It had this kind of blank box in the middle. It typically expects something to be going on, so that's why the box popped up, or really kind of tells you, okay, this is what's going on. So in this case, our I is 6, because our j was 6.0332313. Pretty big. If I click run again, all right, it was 9.06 was our j, and so our I went to 9. Let's see if we can get it to where it's more than 5. There we go. So j is 4.7216125. Our I went to 4. Now, maybe you might have missed why that might be important. The reason that's important is 4.7 would round to 5, following most kind of math ideas. So what this actually does is this truncates, or it cuts off whatever the decimal number is. It just looks at the whole number. All it's looking at is that whole number. There's a way of making it so that it does round, and we'll be talking about that eventually. So I'm going to go ahead and close that out. Oops, close that out. Now, let's change this up a little bit. So go ahead and delete all that. You don't need that anymore. So let's make something. Let's make a background of 0. Make sure you comment on what color that's going to be. Now, let's also make a stroke, not a stroker, a stroke. And we're going to use a couple numbers here. So we're going to go random 255. So that's going to choose a number from 0 all the way up to, but not including, 255. Okay, and we're going to do another random 255 and another random 255. And so hopefully what you're seeing from this is, hey, we're going to have a bunch of random numbers, and this is setting the color for us. All right, let's go and make a line that's from 0, that's the x location, to be a random height, and we'll address that here in a second. And then we're going to put it on the far right hand side, so we're going to do width random height. Oops, not quite done. Another parenthesis there. Now if I run this, hopefully you're kind of already going like, hey, you're missing something. So we have this little tiny box right here. Now, for some people, that's not really doing it for them. And so they're like, all right, we got to get something a little bigger. And so we can do that. We can say, okay, let's set the size to be kind of our typical size, our 200, not two commas, 200, comma, 200. Push the little play button. All right, we're a little bigger. Maybe on my screen, I'm going to make it like 400 or something like that. This depends on how big your actual screen is. I'm using a pretty big screen right now. Now, one thing that you should be noticing is that it's changing color each time I run this. Let's run it again. Run it again. Run it again. You're going to see, hey, look, it's kind of different each time. And it's going to different locations. Some of them appear more than others, and it's not like we have one specific color popping up more than another. I would say, though, the grays are a little more common, but that's to kind of almost be expected. Okay. Now, that was cool and all, but you're still kind of like, let's change a little bit. And we'll come back to that, and we'll get to it in a little bit. So we just did this. So I talked about this a little bit. So println is how we can print information to the console. So if we were to run this specific program, we'd say, okay, we have an integer x, and it's going to be expecting a whole number, so 35. So we print ln, we print a line. The value of x is blank, or is not really blank. The value of x is, and I actually put a space right here, or actually not in this case, I'm looking at it. A comma is actually going to automatically put a space in for you. And it can be sometimes hard of like checking, okay, which like or remembering which one is which, and that's fine, and that happens. Um, Over time, you'll kind of get used to it. Uh, and we've done in the past of having to do these spaces here each time. That's kind of why I led you through that last time. So then you weren't like, what is it's going to mesh together, and then not get why it did mesh together. So in this case, it separates it with a space. Sometimes we don't want that. Sometimes whenever we're trying to make it print something, we want everything to merge together into one. So what we can do is we can use a plus sign. And this plus sign won't print a space automatically. We'd have to tell it specifically, hey, we want you to put a space right here. Again, this is if we want it to run together. Okay. So here's your assignment. Taking some of these ideas, what I want you to do is create a setup and draw function. And what I want these to do is I want the lines to draw from the left side to the right side with a random thickness, random Y locations. It should be from the left to the right. So those two parts, the left side and the right side, should be set. Those should be set values. We actually already did that in the program that we were started. Make it so the colors of the lines change randomly. It kind of makes it more interesting. It's more fun instead of it just being like red the whole time. It like goes red, purple, pink. Um, I've had students call this the rave assignment. So you just make like a little rave going on. So, because as we have them drawn, we want to have them start to fade out. You may, if you don't remember how we did that, you might have to go back into lesson 12.1 and see how did I make this so that it fades. I don't want it to, what we don't want it to do is just instantly be on off. Like, yeah, that's a little more ravey, but it's not as much fun unless you're drawing multiple lines. Additionally, make it print the name of the program in the console whenever you're doing the setup. Make sure you comment on the code and go and submit this into 12.2, 12-2, however your teacher has this set up. Remember to make this into a zipped folder. Like I said last time, there is the how to zip this video. Actually, I said I was going to make it, and then I did make it. So here's this zip this, or check out that zip this folder if you forgot. How do I zip this assignment? As always with the comments, make sure that you put your name in there. That way your teacher can actually identify, okay, who wrote this code. That's everything from me today. So as always, happy coding.